Hey all dear students, here we are again. This is going to be the good time for us because we will learn new topic in ancients, that is, cosmic calendar. The cosmic calendar. A visual representation of the 13.8 billion year history of the universe compressed into a single calendar year. It helps us grasp how recent human history is in the context of cosmic time. So let's begin. What is the cosmic calendar? Created by Carl Sagan, it scales 13.8 billion years of history into one calendar year. Means 12 months. January 1st at midnight equals the Big Bang means it occurs on the date January 1st starting of the year. December 31st at midnight equals right now, present day. So, 1 second equals 437.5 years. And 1 day equals 38 million years. Breakdown of events on the cosmic calendar. January to August. The formation of the universe. January 1st, the Big Bang. Mid-January. First stars and galaxies begin forming. May, the Milky Way galaxy forms. September 1st, our solar system and Earth begin forming. September to November. Early life. September, Earth cools first oceans. September 21st. Oxygen from photosynthesis begins. Cyanobacteria. October. First eukaryotic cells, complex cells. Novi, multicellular life appears. December. Explosion of complex life. December 5th to 14th. Invertebrates, land plants, insects, etc. December 15th to 30th. Dinosaurs dominate. Mammals and birds appear. December 31st, final day. 8 p.m., humans and chimps split. 9:25 p.m. Humans walk upright. 10:30 p.m. Human brain triples in size. 11:52 p.m. Modern humans evolve. 11:56 to 11:59 p.m. Human migration and civilizations. The final minute. Human civilization. 11:59 and 20 seconds p.m. Last ice age ends. 11:59 and 35 seconds p.m. Agriculture begins. 11:59 and 50 seconds p.m. Pyramids, writing, dynasties, Buddha, Bible. 11 hours 59 minutes and 58.8 seconds p.m. Columbus arrives in America. 11 hours 59 minutes and 59.4 seconds p.m. Industrial Revolution begins. 11 hours 59 minutes and 59.8 seconds p.m. Scientific Revolution, World Wars, Internet. The final second. All of modern history. Scientific Revolution, Galileo. Equals 0.9 seconds ago. Industrial Revolution equals 0.6 seconds ago. World Wars, Cold War equals 0.2. 0.1 seconds ago. 9/11 attacks equals just milliseconds ago. Key message. Humanity's entire existence, including all recorded history, every civilization, religion, war, and invention, fits into the last few seconds of December 31st. Why this is powerful. This calendar helps us appreciate the vastness of time and how young human history is compared to the universe. It emphasizes our tiny place in the cosmos, the importance of preserving life and Earth, as it is incredibly rare and recent. Earth's history stretches across 4.6 billion years. But how do scientists make sense of so much time? They use the geological timescale, a powerful system that divides Earth's past into manageable chunks. Let's break it down from largest to smallest. At the top of the timeline, we begin with the eon, the largest unit of geological time. An eon lasts anywhere from 500 million to over 2 billion years. If Earth's entire history was a calendar year, one eon would be 3 to 6 months long. Example: the Phanerozoic eon, where all complex life appears. Next comes the era, a division within an eon. Each era lasts several 100 million years, like a month on our imaginary Earth year calendar. Think of the Mesozoic era, also known as the Age of Dinosaurs. Then we zoom into periods, smaller divisions of time, each lasting 10 to 100 million years. On our calendar, a period would be about a week. Like the Jurassic period, famous for giant dinosaurs and lush vegetation. Go deeper, and we reach the epoch level. These last just a few million years, like a single day in that week. The Holocene epoch began about 10,000 years ago, and it's the one we live in now. And finally, the Age, the smallest unit of geologic time. Lasting hundreds of thousands to a few million years. It's like an hour or even a minute on the geologic clock. Example: the Megalaean Age, which began around 4,200 years ago. So remember, from eons to ages, Earth's timeline is like a cosmic book. And we're just the final word on the last page. Explore more Earth history right here. Imagine this: all 4.6 billion years of Earth's history, squeezed into a single calendar year. A giant clock of creation, where each tick represents millions of years. January. Show Earth forming in fire. In January, Earth is born, a molten planet just forming its crust. March. July. Early oceans, first life. Bacteria evolve, photosynthesis begins, and oxygen fills the air. But still no animals or plants we recognize. August. Complex life emerges. Only in late August do complex, multicellular organisms appear. September. Dinosaurs, reptiles rise. Fast forward to September. Entire eras like the Mesozoic pass. Home to massive dinosaurs and the first mammals. October. Dinosaurs reign. In October, the Earth is alive with towering reptiles and strange plants. But by the end of the month, an asteroid strikes, and the age of dinosaurs is over. November. Mammals take over. Now it's November. Mammals diversify, birds soar, primates evolve. December 31st. The final day. Finally, we reach December 31st. Evening of December 31st. Modern humans evolve. Modern humans appear just a few minutes before midnight. 11:59 p.m. History we know. Everything we call civilization, agriculture, the pyramids, the internet, happens in the last 60 seconds of the year. We are just a blink, a whisper in Earth's epic story. Yet here we are, telling the tale. Don't miss your second in history. Let's journey through time. Not just through years, but through the layers of Earth's deep history. It all begins in the Phanerozoic Eon, starting around 541 million years ago. This is when visible life finally appears in Earth's oceans. From soft-bodied creatures to armored trilobites. Within that vast eon lies the Mesozoic era, the legendary age of dinosaurs, spanning from 252 to 66 million years ago. And inside this era is the Jurassic period, from 201 to 145 million years ago. A time when enormous dinosaurs like Brachiosaurus and Allosaurus ruled the land. And the very first birds took flight. As we zoom in, we reach the late Jurassic epoch. From around 163 to 145 million years ago. This is when sauropods, those long-necked giants, dominated the continents. And finally the Tithonian Age, the very last chapter of the Jurassic period. It lasted from about 152 to 145 million years ago, marking the final breath of the Jurassic world before the rise of new ecosystems. From eons to ages, every layer tells a story, and every fossil, a whisper from Earth's living past. Let's break down Earth's history, from its grandest divisions to its finest details. At the very top we have the eon, the largest unit of geological time. Each eon lasts up to 2 billion years and contains multiple eras. Example: the Phanerozoic eon, where visible life first appears. Next comes the era, still massive, lasting hundreds of millions of years. Eras divide eons into powerful chapters like the Mesozoic era, the time when dinosaurs ruled the Earth. Then we reach the period, a medium-scale division lasting 10 to 100 million years. Like the Jurassic period, known for its lush greenery and giant reptiles. Smaller still are the epochs, spanning a few million years each. These track changes in climate and life like the Holocene epoch, where humans began farming and building cities. And finally we arrive at the age, the smallest division of time. Each age may last a few thousand to a million years. For example, the Megalayan age, which began just 4,200 years ago, and continues to this day. From eons to ages, Earth's timeline is a staircase of change, and we are standing on the top step. Geological timescale. Explained in detail. The geological timescale, GTS, is a system used by scientists to describe the timing and relationships between events that occurred throughout Earth's 4.6 billion-year history. It is divided into hierarchical time units: eons largest, eras, periods, epochs, ages, optional finer units. Earth is ancient. Its story spans 4.6 billion years, divided into 4 colossal chapters called eons. Hadean eon, 4,600 to 4,000 million years ago. The Hadean eon, the Earth's fiery birth. Time of molten rock, crashing asteroids, and no life. The planet was forming its crust, but it was still too hot for oceans or organisms. Archean eon, 4000 to 2500 ME. Next came the Archean eon. As Earth cooled, oceans began to form. And deep within those waters, the first life appeared. Simple cells known as prokaryotes. Bacteria ruled the planet, and the earliest rocks were laid. Proterozoic eon, 2500 to 541 ME. In the Proterozoic eon, something remarkable happened. Oxygen began to fill the atmosphere, thanks to tiny photosynthetic microbes. This sparked the rise of more complex cells, eukaryotes, and eventually the first multicellular life. Phanerozoic eon, 541 A. Now. Finally, the Phanerozoic eon, the era of visible life, where things truly come alive. Fossils tell the story of explosive biodiversity. From trilobites to dinosaurs to mammals. And finally to humans. From fire and stone to forests and cities. These 4 eons shaped every chapter of Earth's story. And we're living in the most recent page. 2. Eras, subdivisions of eons. The Phanerozoic eon is divided into 3 eras. Era time frame nickname/highlights. Paleozoic 541 to 252 m. Age of marine life. First fish, land plants, amphibians. Mesozoic 252 to 66 an. Age of reptiles. Dinosaurs, birds, flowering plants. Cenozoic 66 m. Present age of mammals. Mammals dominate, humans appear. 3. Periods. Subdivisions of eras. Paleozoic era periods. Period time. Key events. Cambrian 541 to 485 Cambrian explosion. Diversity of marine life. Ordovician 485 to 443 first fish, corals. Silurian 443 to 419 first land plants. Devonian 419 to 359 first amphibians, forests. Carboniferous, Mississippian plus Pennsylvanian. 359 to 299 coal-forming forests, first reptiles. Permian 299 to 252 supercontinent Pangea forms, ends in largest mass extinction. Mesozoic era periods. Period time. Key events. Triassic 252 to 201 first dinosaurs and mammals. Jurassic 201 to 145 dinosaurs dominate. First birds. Cretaceous 145 to 66 flowering plants appear. Ends with dinosaur extinction. Cenozoic era periods. Period time. Key events. Paleogene 66 to 23 mammals diversify. Primates evolve. Neogene 23 to 2.6 grasslands expand. Early humans evolve. Quaternary 2.6. Now Ice Ages, modern human civilizations develop. When the dinosaurs vanished, a new era began. Welcome to the Cenozoic era, the age of mammals. Divided into smaller chapters called epochs. Each one brings us closer to today. Paleocene epoch, 66 to 56 million years ago. In the Paleocene, Earth is recovering. The dinosaurs are gone. And mammals are quietly starting to take over. Eocene epoch, 56 to 34. Next comes the Eocene. A warm, tropical Earth, filled with dense forests. And the rise of the first primates. Oligocene epoch, 34 to 23. In the Oligocene, the world begins to cool. Forests shrink. Grasslands begin to spread. And the first true monkeys swing into view. Miocene epoch, 23 to 5.3. The Miocene is a time of evolution and expansion. Apes evolve and roam freely, while vast grasslands dominate the landscape. Pliocene epoch, 5.3 to 2.6. In the Pliocene, the stage is set for humanity. Early human ancestors emerge. And Earth's climate continues to cool. Pleistocene epoch, 2.6 0.01. Then comes the Pleistocene, a time of ice ages, woolly mammoths, and the appearance of Homo sapiens, our species. Holocene epoch, 0.01 present. And finally the Holocene. The modern world is born. We build farms, cities, languages, civilizations. Everything we call history fits into this tiny sliver of time. From jungle apes to rocket ships, the epochs of the Cenozoic tell the story of how we got here. And the story isn't over yet. 5. Major evolutionary and geologic milestones. Time event. 4,600 Earth forms. 3,800 first life, bacteria. 2,500 oxygen begins accumulating. 600 first multicellular life. 541 Cambrian explosion. 375 first amphibians. 252 largest mass extinction. 230 first dinosaurs. 66 dinosaurs extinct. Mammals rise. 2.6 ice ages begin. 0.01 humans dominate planet. Why is the geological timescale important? Helps us understand Earth's evolution, climate changes, and extinction events. Used by geologists and paleontologists to date fossils and rock layers. Shows the slow, step-by-step development of life over billions of years. Congratulations! Now you have gained the knowledge of geological time, so I think you are ready for next move on evolution topic. So this is a chart very important for exam. Now we will understand this chart with geological time frame. Understanding the columns. Left columns. Eon, largest division of time. Hadean, Archean, Proterozoic, Phanerozoic. Era of subdivisions of eons, e.g. Paleozoic, Mesozoic, Cenozoic. Period and epoch finer subdivisions, like Cambrian, Jurassic, Quaternary. A million years ago, when each time unit started. Middle columns. Life forms, major biological events, e.g. first reptiles, extinction events. North American events, major geological events on the continent, e.g. mountain building orogenes. 1. Precambrian time, 4,600 to 541, covers 88% of Earth's history. Hadean, Archean, Proterozoic eons. Formation of Earth, 4.6 BY. Origin of life, 3.8 BY. Bacteria, algae, stromatolites, Simple and complex multicellular life appears. Major rock formations, supercontinents form. 2. Phanerozoic Eon, 541 A. Present. The time of visible life. Paleozoic era, 541 to 252 m. Age of marine invertebrates, fishes, amphibians. Period major life events. Cambrian explosion of life, early shelled organisms. Ordovician trilobites, primitive fish, first corals. Silurian first land plants, jawed fish. Devonian first amphibians, forests, mass extinction. Mississippian and Pennsylvanian first reptiles. Coal swamps, sharks. Permian reptiles dominate. Ends in largest mass extinction. Mesozoic era, 252 to 66 and Age of reptiles. Period major life events. Triassic first dinosaurs and mammals. Breakup of Pangaea. Jurassic dinosaurs dominate. Flying reptiles, first birds. Cretaceous flowering plants, extinction of dinosaurs, ends era. Ends with a mass extinction, 66 MA. Likely due to asteroid impact. Cenozoic era, 66 present. Age of mammals. Period epochs major life events. Paleogene Paleocene to Oligocene early primates. Mammals evolve. Neogene Miocene to Pliocene grasslands expand. Early human ancestors appear. Quaternary Pleistocene, Holocene ice ages. Modern humans extinction of megafauna. Mass extinctions marked in red. Ordovician, 444 A. Marine species die off. Devonian, 359 A. Affects ocean life. Permian, 252 Ma. Largest extinction, 95% species lost. Triassic, 201 A. Reptiles survive, dinosaurs rise. Cretaceous, 66 A. Dinosaurs extinct, mammals rise. North American events. Orogeny equals mountain building event. E.g., Appalachian, Rocky, Nevadan, severe orogenies. These show how land masses shifted and mountains formed over geologic time. Summary timeline condensed. Time events. 4.6 BY Earth formed. 3.5 BY life began. 541 May explosion of visible life. 252 dinosaurs appear. 66 May dinosaurs extinct. Mammals dominate. 0.01 May modern humans evolve. Now let's take one particular example of evolution. The evolution of the horse over the last 55 million years, from a small forest-dwelling ancestor to the modern horse we see today. It includes timeline, skeletal changes, especially the foot bones, and body size. The image is scientifically scaled and highlights evolutionary adaptations in response to environmental changes. Evolution of the horse. Explained step by step. Timeline overview. Epoch millions of years ago, key horse ancestors. Eocene 55 to 34 Hyracotherium Eohippus. Oligocene 34 to 23 Orohippus. Epihippus. Mesohippus, Myohippus. Miocene 23 to 5.3 Anchitherium. Parahippus, Merychippus. Pliocene 5.3 to 2.6 Pliohippus, Hipparion. Pleistocene. Holocene 2.6 Present equus, modern horses. Major stages in horse evolution. Hyracotherium Eohippus. 55 Isen. Size. 30-40 cm tall, like a small dog. Lived in dense forests. Features. 4 toes on front feet, 3 toes on hind feet. Teeth adapted for soft leaves. Dawn horse. First known horse ancestor. Myohippus. 30 Oligocene. Larger body, longer legs. 3 main toes, middle toe becoming more dominant. Lived in open woodlands, start of adapting to faster running. Merychippus. 17 Miocene. Important transitional species. Size, pony-sized. Fully adapted to grazing. Teeth evolved for grass. Legs longer, better adapted for speed. Middle toe fully weight-bearing, side toes reduced. Sign of shift from forests grasslands. 4. Pliohippus hipparion. And 5. Pliocene. More advanced running structure. Single-hoofed toe developed. Most side toes completely reduced. 5. Equus, modern horses. 2.6 MWA present. Includes thoroughbred Przewalski's horse. Fully single-hoofed foot. Teeth adapted for tough grasses. Fast runners, excellent grazers. Survived ice ages and domesticated by humans. Forefoot evolution, toes/leg bones. Ancestor toes on front foot notes. Hyracotherium 4 toes forest dweller, soft ground. Myohippus 3 toes faster runner, stronger middle toe. Merychippus 3 toes, middle enlarged, shift toward hoof running. Equus, modern 1 toe, hoof. Fully hoofed for grassland speed. Trend. More efficient running, fewer toes, longer limbs. Key evolutionary trends. Increase in size. Toes reduced, single hoof. Teeth changed from leaf eating to grass eating. Legs lengthen, better for running. Adaptation to grassland environments.